Hello and welcome to the 14th session of the Rapid Revision Crash Course for UPSC Prelims 2026 by Shikara Academy. In this session, we will discuss about global warming. What is global warming? How it is different from climate change, about the greenhouse effect, the greenhouse gases, the causes of global warming, and most importantly, the impact and effects of global warming. Now, we use the terms climate change and global warming quite interchangeably, but there is certain difference between these two terms. Climate change, in simple terms, is the long-term shift in the weather patterns. That is, there are mainly three factors that determine the weather of an area. That is, the temperature, the rainfall or the moisture, and the wind. Okay, so these three are the factors that determine the weather. So a long-term change or a long-term shift in the weather patterns is climate change. Now, the climate change can both be natural and it can be human induced. So over the entire course of history of the planet, most of the climate change events were mainly driven by natural factors. But in last 150 years, what we have seen that the climate change is now being driven by the human factors or the anthropogenic factors. The global warming, on the other hand, is the specific long-term rise in the Earth's average temperature. So warming is the rise in temperature. So an average long-term rise in the average temperature of Earth's atmosphere and the surface of the Earth is known as global warming. And global warming is mainly driven by the anthropogenic factors like the release of the greenhouse gases. Okay. So as we can see that as of present, it is the anthropogenic factors that is mostly contributing towards the greenhouse effect as well as towards the global warming as well as the climate change. Now let's talk about the phenomena of the process behind this warming, that is the greenhouse effect. So we all know that the solar radiation that comes on the earth. Okay, so we receive the solar radiation. So we have incoming energy that passes through the atmosphere. This is the surface of the earth. This is our atmosphere. And we receive the short wave solar radiation. Okay, such solar radiations that have shorter wavelengths. Now, these waves, they pass through the atmosphere, they reach the surface of the earth, they warm up the earth. They warms up the surface of the earth, and then the surface of the earth then starts to emit the longer wave infrared radiation. Okay, so the waves, the short wave solar radiation are allowed by the atmosphere to pass through, but these long wave infrared radiation, these are trapped by the greenhouse gases. These are trapped by the atmosphere, and in the atmosphere, mainly by the greenhouse gases that are present. Okay. So the greenhouse gases absorb and re-emit the heat, thereby warming the atmosphere. Okay. Warming the average temperature of the atmosphere. Now, this process is quite a natural process. Okay, and it is essential to support life on the planet Earth. It's a natural effect because it maintains a habitable 15 degrees Celsius average temperature on the planet Earth. Because of the human factors, we have added more and more of these greenhouse gases into the atmosphere. And because of that, a lot of this long wave infrared radiation is being trapped into the atmosphere. Therefore, and the energy or the heat is re-emitting, and the average temperature of the atmosphere is increasing. So the anthropogenic thickening of the layer acts like a glass roof and it destabilizes the thermal equilibrium. Now, what are these greenhouse gases? So the greenhouse gases, these are mainly the gases which are responsible for the greenhouse gas effect. That means these are the gases that trap the outgoing solar radiation, the terrestrial radiations from the Earth. So we have carbon dioxide as the main greenhouse gas, and we have methane and the nitrous oxide. These three are known as the big three greenhouse gas. Okay, so the greenhouse gases are referred as GHGs. So carbon dioxide is emitted from burning of fossil fuel combustion, deforestation, as well as cement production. The methane, the major source is the livestock digestion, the paddy fields, landfills, as well as the natural gas leakage. The nitrous oxide, so please note that it's the nitrous oxide, not the nitrogen dioxide or the nitrogen oxide. So it is N2O. Now, This is released by the synthetic fertilizers, by the fossil fuel combustion, and burning of the crop residues or the stubble burning. Then we have these fluorinated gases. These are also very potent greenhouse gases. Example, we have the hydrofluorocarbons, the perfluorocarbons, and the sulfur hexafluoride. These are man-made compounds, these are man-made gases, and mainly are used in industries like the refrigeration, aluminum production, as well as the semiconductor manufacturing. Then we have the water vapor. Now, water vapor is also, it behaves as a greenhouse gas because it absorbs both incoming solar as well as the outgoing terrestrial radiation. Now, how do we determine which of these greenhouse gases they are more potent? For that, we have the global warming potential. If we have to measure the potency of these greenhouse gases, we have the global warming potential. That is the potential or the potency of the greenhouse gas to absorb the heat relative to 1 ton of carbon dioxide over 100 years. So the carbon dioxide is the scale to which we relate. Okay, relative to carbon dioxide, what is the global warming potential of a gas? Okay, so we assign the number one to the carbon dioxide. This is the baseline because the carbon dioxide in the atmosphere, it has an average lifespan of 50 to 200 years. The methane gas, its lifetime in the atmosphere is less, but it is 25 times more potent than the carbon dioxide. When we have nitrous oxide, its lifespan is something around 100, 125, 120 years, and it is 300 times more potent than the carbon dioxide. That means 1 ton of nitrous oxide over 100 periods, or over a 100-year period, will be 300 times, will absorb 300 times more solar radiation or the terrestrial radiation than the 1 ton of carbon. Then we have the sulfur hexafluoride or the SF6. Now, it's a very long lasting gas, that is, its lifetime is 3200 years, and its potency is many, many thousand times greater than the carbon dioxide, approximately 24,000. So it's a super pollutant. It has extremely high potency and it is also persistent. Okay, it has a high potency and it remains in the atmosphere for a very long time. Now, beyond the gases, we have the particulate matter as well as that also contribute towards the global warming. So we have the black carbon or the soot. Now these are the solid particles that are emitted from incomplete combustion. So complete combustion gives us carbon dioxide. The incomplete combustion gives us the black carbon or the soot. Now this black carbon, it absorbs the sunlight directly, thereby heating the air. And it does another bad thing is that it darkens the snow or ice upon settling. So it remains suspended into the atmosphere, but it's quite heavy as compared to other gases. It's a solid particulate matter. It settles down on the ground. Now, if it settles down on the ice or on the snow, it decreases the albedo. Okay. So now what is the albedo? The albedo is the ratio of the sunlight a surface reflects divided by the amount of sunlight a surface absorbs. Okay. We have the another particulate matter, that is the brown carbon, which are organic aerosols that are primarily from the biomass combustion. So how this albedo feedback loop works? So we have the warming climate. Okay. Because of the warming climate, the snow melts, snow or ice melts. Now, the ice or snow, because it is white, because whiter surfaces, they have high albedo. That means they reflect most of the sunlight. But when uh, they become water, okay, when they melt, okay, their albedo comes down. Okay, their albedo comes down because now they absorb more of the solar radiation rather than reflecting it back. So there is reduced albedo, that is, there is reduced reflectivity. Now, because of that, this water body will start to warm up more. Okay, it will absorb more heat and it will warm up more, thereby melting the nearby ice caps as well. So it's like a vicious cycle or a vicious loop. Now, apart from these are the man-made factors that we have discussed, but there are some historical natural causes of the climate change or the global warming as well. Now, these are variations in the solar cycle. Okay, because in every 11 years, the sunspot intensity on the surface of the sun, it increases. So sunspots are the area of very high magnetic activity, and these are cooler areas, darker and cooler areas on the sun. Now, when the solar activity, okay, when there are more and more of these sunspots, we say that the solar activity is very high. And that high solar activity corresponds to more of the solar radiation. Okay, and as a result, the temperature of the earth goes up. Then there are Milankovitch cycles. Now, these are uh, influenced by the changes in the Earth's orbit, in the Earth's tilt, as well as the in the Earth's eccentricity. Then there is volcanism. Okay, volcanic eruption is a natural process. Now, the emissions from these volcanoes, okay, the aerosols that release from the volcanoes, they get suspended into the atmosphere, and the volcanic eruptions also release a massive amount of carbon dioxide, thereby further warming the atmosphere. Now, if we have to discuss the anthropogenic factors, the biggest factor is the energy supply sector. So, the energy sector is the primary driver. That is, we burn the fossil fuels mainly. The burning of coal, the burning of fossil fuels like the petroleum or the petrol, diesel, the gases, natural gas for electricity. This is the major contributor to the for the greenhouse gases into the atmosphere. Then there is industry. There is agriculture, forestry, and change in land use is a very significant factor. Then there is the transport sector and the buildings, the household buildings or the commercial building sector. So if we have to arrange these five sectors in decreasing order, the energy sector, followed by industry, agriculture, forestry and land use, then there is transport and the building sector. Now, so, what's the evidence of the climate change or the global warming? Okay, so over the years, we have seen that there has been highest concentrations in at least last 2 million years. There has been highest concentration of carbon dioxide into the atmosphere, that is 419 parts per million. There has been a rise in the sea level of zero point 0.2 meters between the year 1901 to 2018. So over a period of 117 years, there has been zero point 0.2 meter rise in the sea level. Then there is cryosphere. The cryosphere is the snow-covered area of the Earth that comprise of the various glaciers, the polar ice caps that are there. So the in cryosphere we have the lowest ice since the 1850, and the average sea surface temperature, there has been 1 degree Celsius rise in the Indian Ocean region. Okay, so we have from 1951 to 2015, in less than 75 years, the Indian Ocean surface temperature sea surface temperature has rose by 1 degree Celsius. Now, what are the impacts of the climate change or the global warming? First is the ocean acidification. There are triple threats that are associated with the oceans. That is increasing acidity of the oceans, that is decreasing the pH of the ocean water, because the carbon dioxide, it gets, if more and more carbon dioxide is there into the atmosphere, it gets dissolved into the seawater, and as a result it becomes carbonic acid and it decreases the pH of the ocean water or the seawater. Then there is warming of the ocean water, the second threat. And the third threat is the reduced amount of oxygen in the ocean water. Okay, so the warmer, the deoxygenated, reduced, and more acidic. These are the three impacts on the oceans. Because of that, the carbonic acid that steals the carbonate needed for the shell building. Because of that, these organisms that have the carbonate shells, the carbonate shell gets dissolved. Then there is an interaction with the ozone connection as well. So the polar stratospheric clouds provide the surface for hydrolysis, and there is accelerating ozone hole formation in the Antarctic during the winter months. And there is impact on human food security as well as the ecosystems. Okay. So there is carbon dioxide fertilization paradox. Now, why is this paradox? It means the initial greening from the photosynthesis, because the carbon dioxide is one of the inputs in the process of photosynthesis. Plants require the carbon dioxide for the photosynthesis to produce food and to release oxygen. Now, If the amount or the concentration of carbon dioxide into the atmosphere increases over a period of increases to a certain period, to a certain extent, then we see an increase in the photosynthetic activity. Okay, but it is up to a certain level only. Beyond that, what we see is the nutrient loss and the heat stress. Then there is yield disparity. The yield comes down. In the temperate regions, there is potential short-term benefits up to 1 to 3 degrees Celsius if the in the temperate areas, in the subtropical or in polar areas, the agriculture productivity or plant productivity, it improves up to 1 to 3 degrees Celsius. But in the tropical areas, there is immediate negative impact on wheat, rice, as well as maize cultivation. And we also can witness the ecosystem collapse. And the prime example is the coral bleaching. Now, with the warming of the ocean water and the increasing acidification of the ocean water, we are witnessing the phenomena of coral bleaching where the corals expel the zooxanthellae algae that lives in symbiotic association with the corals. And when the so we have the xanthellid algae. Now this algae lives in symbiotic relationship with the corals due to stress. Okay, because of the increased warming as well as because of the lower pH. The corals, they kick out these zooxanthellae algae. And these zooxanthellae algae were the ones which were giving colors to the coral. And when the zooxanthellae algae or the symbiotic relationship ends, okay, the corals, they become white or colorless. And that is known as coral bleaching. Then it forms the dead zones, that is anoxic waters causing the marine life to collapse. Dead zones means such zones where the concentration of oxygen is so less that it cannot sustain life. And we also witness migration, that is the species, the marine species, they move to the higher latitudes or the altitudes. Okay, be it the species on the ground as well as the species on in the water, they try to move to the cooler areas. Now, talking about the cost on human health, okay, so we see a rise in the vector-borne disease, particularly the tropical vector-borne disease like the malaria, dengue. There is a heat stress because of which we see high mortality among elderly people and the vulnerable people. Also, there is a displacement, there is loss of coastal lands and the salt water intrusion. What happens is because the cryosphere is melting, that is increasing the water that is there in the oceans, and thereby what we see is the erosion or the loss of the coastal lands. Okay, the coastal cities, they are at the risk of getting submerged into the water. Okay, and we see another effect, that is the urban heat island effect. Now this urban heat island effect is because of the concrete mainly. So the concrete in cities, we have a lot of the buildings that are made up of concrete. Even the pavements, they are made up of the footpaths, they are made up of concrete. So the concrete, it absorbs a lot of heat. Okay, and we also have the vehicular exhausts and we have the exhaust from the buildings. Okay. So they create a urban heat island effect. That means in the urban area as compared to the surrounding area, the urban area has a higher temperature as compared to the surroundings. The surroundings are cooler, but the urban area is warmer or hotter. So concrete in the building, concrete in the roads, it absorbs the heat. Also, because there are less of the trees, so there is a lack of evapotranspiration. This evapotranspiration causes cooling. Okay, so because of the lack of evapotranspiration, the cooling effect also dies down. But how can we make sure that the greenhouse gases are not, we are not emitting a lot of these greenhouse gases? How do we mitigate these things? So we have the clean coal and efficiency. We can make use of the electrostatic precipitator so that the emissions that are there from burning of the coal or the fossil fuels, okay, it gets limited to the atmosphere. Then we can capture the carbon and store it. Okay, so in the depleted oil fields, that is the sedimentary rocks in which we earlier found the oils and we have extracted all the oils. So these depleted oil fields, we can capture the carbon and we can place that carbon, we can store that carbon into these depleted oil fields, thereby removing carbon dioxide from the atmosphere. Then we can transition to the renewable energy like the solar energy or the wind energy because they do not emit the greenhouse gases. Also, we can plant more and more trees, afforestation as well as reforestation, because the plants, they help to sequester the carbon. They help in carbon sequestration. That is, they provide a sink to the carbon dioxide. So they capture the carbon dioxide from the atmosphere. Okay. So warming risks turning the sinks into the sources. And the soil is one of the biggest sink of the carbon dioxide. Okay. Also, the adaptation strategies that we have to focus in agriculture, there is crop rotation, precision farming, as well as the floating farms, as there is case in the Bangladesh. Then infrastructure, we can build the flood barriers, the green roofs, and the permeable pavements. Now, internationally, this has been a huge issue, and debates are going on. And in 1992, we had the Rio Earth Summit. Okay, and as a result of the Rio Earth Summit, we had the United Nations Framework Convention on Climate Change. Okay, under the UNFCCC, in the third conference of party, we had the Kyoto Protocol in 1997, and then we moved or we evolved to the Paris Agreement in 2015 and in COP 21. Under the Paris Agreement, the countries, they have declared their nationally determined contributions, and these need to be updated every 5 years. We have discussed in detail about the UNFCCC, its objectives, its various mechanisms, its various conference of parties detailed in the previous sessions. You can go and have a look. Okay. So we have to balance the mitigation, that is, we have to reduce the emissions. Also, we have to go for adaptation, that is, we have to build the resilience. Resilience from what? Resilience from the negative impact of the global warming, negative impact like the rise in the sea level. Okay. How can we adapt to that thing? Okay, that comes under adaptation. Now, for the aspirants of the APPSC Group 2 examination, we at Shikara Academy are thrilled to announce our foundation batch. The batch starts from 9th of Feb, and in the batch, you will be provided with live and recorded classes, 100% GS syllabus coverage with comprehensive current affairs coverage, and a special focus on subject-wise and full-length test series with study materials and resources, and personalized mentorship by very experienced faculty. So if you register before 24th Jan or by today midnight, you get an extra 1000 off. And we also have a Republic Day offer in which you can avail this program at 9,999. And if you register today or if you show interest today, you can get further rupees 1000 off. Now, summarizing what we have discussed till now. So, global warming, the drivers and the damage. So the drivers of the global warming are the burning of fossil fuels, deforestation, and industrial processes. Okay. So we have discussed the various sectors like energy sector, the industrial sector, the agriculture, forest, and land use, transport sector, and the building sector. There are greenhouse gases. Some are more potent, some are less potent. So carbon dioxide is the most abundant greenhouse gas. The and the other gases like the methane, the nitrous oxide, the sulfur hexafluoride, these are way more potent than the carbon dioxide in terms of the global warming potency. Now, because of that, what we are witnessing is the rising temperature and melting ice. Oceans, they face the triple threat of warming, more acidic, and losing oxygen. And because of that, we are witnessing extreme weather conditions like hurricanes, flooding, droughts, and heat waves.